Okay, so, on to me. This study is on the Floristics of KwaZulu-Natal Sandstone Sourveld within the eThekwini municipal area. It forms part of an MSc by myself and supervised by Drs. Sid Ramdani and Surshan Naidu of UKZN and Dr. Clinton Corbett of Ezemvelo. So, the big picture. Globalization and urbanization are known to impact natural systems. Globalization and urbanization often lead to transformation, which is known to impact highly on grasslands. Transformation often leads to a need for conservation. But before we can conserve an area, we need to know what is there and what it classifies as. In the same way in which we cannot apply the same conservation practices to a mangrove and an estuary and expect the same outcomes, so too we cannot apply the same conservation practices to different grasslands and expect the same outcomes. Grasslands are traditionally thought of as homogeneous in species composition and vegetation structure. However, this is not the case. In the eThekwini municipal area, or Durban, we have subtropical grasslands. These grasslands are thought to have extended from the coastal dune forest all the way into your highland grasslands. However, and were broken up by small patches of forest in deep ravines and gullies. However, nowadays, suburbia, urban areas and forests are broken up by small patches of grasslands. These grasslands have a long history of classification, beginning with Acox through to Low and Rebello and most recently Messina and Rutherford. Currently, within the eThekwini municipal area are three main grassland types. Ngoni Veld, listed as SVS4, KwaZulu-Natal Sandstone Sourveld, listed as SVS5, and Indian Ocean Coastal Belt Grassland, listed as CB3. So, what this study aims at and why? This study aims to delineate KZNSS from Indian Ocean Coastal Belt Grassland by the use of vegetation analyses. Little of KwaZulu-Natal Sandstone Sourveld remains within the eThekwini municipal area and appears similar to Indian Ocean Coastal Belt Grassland, which I'll go into a bit later on. The objectives of this study specifically were to compare the sites in terms of alpha and beta diversity, to compare the above and below ground flora, and to compare the sites in an island biogeography framework. KwaZulu-Natal Sandstone Sourveld and IOCBG. These two different types have quite a large overlap in range and areas in which they are found, as well as altitude. They have similar geology, land use history, and altitude, which can all lead to similarities and differences in the vegetation. On the left, the picture is of a typical confirmed KwaZulu-Natal Sandstone Sourveld site, and on the right, we have a typical confirmed Indian Ocean Coastal Belt Grasslands site. These photos were taken roughly a month apart. So, methods for this study. For this study, 8 sites were selected. They were grouped into 3 groupings. The first, shown in purple, is true KwaZulu-Natal Sandstone Sourveld. I will use purple to denote true KwaZulu-Natal Sandstone Sourveld for the remainder of this presentation. Green shows Indian Ocean Coastal Belt Grassland. And lastly, pink in the middle, we called ecotonal. These ecotonal sites, which there are 3 of, are less than 350 meters away from KwaZulu-Natal Sandstone Sourveld, but are currently classified as Indian Ocean Coastal Belt Grassland, with similar altitudes to that of KwaZulu-Natal Sandstone Sourveld. Floristic analyses were performed to see if these groups were different, and if so, which species and species associations led to these differences. This was done by the use of standard 5x5 meter quadrats, accompanied by monthly transects and walkthroughs, and statistics, which I'm sure are far more exciting to me than they are to you. For the objective of comparing the above and below ground flora, the germinable soil seed bank was studied. But before I go into how it was studied, I just want to explain why we bothered to look at it at all. Examining the germinable soil seed bank can give us insights into the future and past of a site in a way in which examining the above-ground flora cannot. For example, if we find an invasive alien species hiding in the germinable soil seed bank, we can prepare for its imminent invasion in the above-ground flora and stop the invasion before it gets a chance to spread too much. So, how this was done: soil samples were removed, placed on top of Grovida, which is the bottom part over there. There's the soil sample over there. Placed under a shade cloth, right there, for 5 months and allowed to germinate, as you can see happening through hundreds and hundreds of pots. Samples were removed in late autumn and late spring. For each site, 30 samples per season were taken. Results thus far. So it's quite a complicated table. Well, not very complicated, just very big. So let's go through it together. The number of species by quadrats refers only to the species found in the quadrats. For several of the sites, sufficient sampling or an 80% sampling effort according to Chow and Jack have not yet been found. Chow 2, Jack 1. And so these numbers are expected to rise. The total number of species refers to the number of species found in the quadrats as well as in the monthly walkthroughs. Even though there is quite a large increase for each of the different groups and for each of the different sites, which is not displayed, the difference between the total from quadrats and the total by species is not that great. There was quite a lot of overlap when we looked at the presence-absence data, and species which were rare and not picked up in the quadrats of some groups were quite common and picked up in the quadrats of another group. Okay, so this diagram is based on the total number of species given and includes only presence-absence values. We have 91 species common to IOCBG, KZNSS, and ecotonal. We have 29 species unique to KZNSS, 28 unique to ecotonal, 17 unique to IOCBG. We have 34 species which are common to ecotonal and KZNSS. We have 15 common to ecotonal and IOCBG, and 12 common to IOCBG and KZNSS. This indicates to us preliminary that ecotonal may be closer to KZNSS than it is to IOCBG, which it is currently classified as. Clustering analyses were performed. 8 different analyses were run. Shown here is the statistically most significant. The sites are given with the boxes representing their grouping. Two main clusters are found. This first, the smallest one here, consists of a highly transformed and currently being rehabilitated ecotonal site, as well as one site which only had sampling begun in May and was then burnt in May, and so does not have a lot of data, only 36 species represented. The main group here shows some separation between KZNSS, ecotonal, and IOCBG. However, the separation is not all that great. The separation does not also seem to be driven by altitude. The altitudes of the sites are given as well, and the number of species included for this analysis are also given. 2 types of ordinations were performed. 12 different ordinations were performed for each type of ordination and the best results selected. For this ordination, we used the average abundance of quadrats. For this ordination, one of the IOCBG sites was excluded, as at the time of analysis, it only had 4 quadrats performed, and compared to the rest, which had a minimum of 10 quadrats performed, didn't seem to work very well. We see the highly transformed site groups out, whilst the rest of the sites tend to go close together. The ecotonal site seems somewhat separated. The second type of ordination that was performed was done on using the individual quadrats abundance data. The highly transformed site's quadrats sit somewhat near the top, whilst the remaining sites, green, pink, and purple, group quite closely together along the axis there with just a few outliers on the bottom. What does it mean? Some results show no separation, whilst others show some separation between these three groups. Some results indicate that perhaps KZNSS and ecotonal are more similar, whilst others indicate that ecotonal is more closely related to IOCBG. These differences seem to be based more on composition than on structure. The study provides a good start in providing information which can lead to better management practices. The study also indicates that perhaps degradation may be leading to homogenization, where degraded ecotonal sites may become to resemble Indian Ocean coastal belt grassland. However, more data is needed for further refining. This approach can be used for future studies. I'd just like to acknowledge the following people: my funders, Teddy Govender for identification assistance, Saffron Mace for assisting in the field, and the landowners and reserve managers for access to their respective reserves and land parcels.